average acceleration. That's where you take the slope. It would be these numbers, v of 50 minus v of 0, because the slope of the velocity is acceleration. So that's why we're not finding the acceleration first. Over 50 minus 0. Okay, so looking at the chart, v of 50 is 72, and v of 0 is 0. So it's 72 over 50, which is 36 over 25. We could use a calculator, whatever the calculator would be. If we couldn't, you could actually, on a free response question, you could leave it like this. You could leave it as 72 minus 0 over 50. As long as all you'd have left to do is type it into a calculator, you're fine. You don't have to do any more work than that. You don't have to simplify it, anything like that. You can, but just if you make a mistake from here to here, they're going to count off. Whereas if you leave it like this, you're going to get full credit. So they're very okay with not simplifying on the free response questions. Now, multiple choice, you have to find it, they're going to expect you to simplify because their answer is going to be simplified. But free response question, you're fine. Less is more. C, find one approximation for the acceleration of the car at t equals 40. Show the computations you used to arrive at your answer. So first off, it says approximation. So that helps. For the acceleration of a car at t equals 40. So acceleration, that's v prime of 40. Which is the same thing as a, the acceleration of 40. And we can do the same thing we did up here, only we want it to be for 40. So you could use, say, like from 35 to 45. You could use those 2 points as an approximation for 40. You could also use, as long as you show your work, you could use, say, 35 and 40. You could also use 40 and 45. We're just approximating. So as long as you show your work, there's really, unless you're like way off, it's going to be fine. So I'm going to use these two just because that's what I used in my notes. And because 40 is in between those two. And the big thing that helps us realize, oh, we're doing a slope, is that it says approximation. So it's going to be v of, 45 minus v of 35 over 45 minus 35. V of 45 is 60. And V of 35 is 81 over 10. So that right there is fine. That would be fine for an answer. If you left that on a free response question on the test, I would give it to you. I would also be totally fine if you reduced it. And let's see, the units would be feet per second. Oh, this should have been squared. The one up there was squared too because it's approximating acceleration. Okay, so other than realizing the average acceleration is the slope of velocity, we're doing very little calculus here. It's mostly, just knowing those terms. On D, is the speed of the car increasing or decreasing? For speed, remember you have to look at velocity and acceleration, and they have to be, if it's increasing, the same. If it's decreasing, different. So if I do velocity at 40, from this table, it's 75, which is positive. And V prime of 40 was approximately, we just found it, negative 21 over 10. Or if you looked at the picture, you could just say because at 40 it is decreasing, you could just say it's negative. It doesn't matter if you know exactly what it is, but you know the slope is decreasing there. Either way. So because of those two things, the speed of the car at t equals 40 seconds is slowing down or decreasing because V of 40 is positive and V prime of 40 is negative. So because they're opposite, that's a good free response question. And it wasn't kind of, it wasn't really impossible. A lot of them seem impossible. The catch is to push through it even when it gets hard. Do what you can and keep going, because just because part A is hard doesn't mean that you can't do part B or so on and so forth. And it's important to, get as many points as you can. Okay, two runners, A and B, run on a straight, we're on page 411. Two runners, A and B, run on a straight racetrack for 0 to 10 seconds. The graph below, which consists of two line segments, shows velocity. So that's important. Velocity in meters per second of runner A. The velocity in meters per second of runner B is given by this equation. Okay, A. Find the velocity of runner A and the velocity of runner B at t equals 2 seconds. Indicate units of measure. Okay. So for runner A, we could try to use this graph, but even if you do have it right there in front of you, but it doesn't come out nice and neat. It's like, not quite 6, actually, somewhere between 6 and 7. So to find it exactly, because it doesn't say approximate or anything, we're just going to use this line. This is a line, just like in Algebra 1. So for runner A, we know we have a line here with 2 points. That's just a line. It's y equals mx plus b. And we know our m, our slope, is using those 2 points, 0, 0, and 3, 10. It is y2 minus y1 over x2 minus x1. So the slope is 10/3. And then the y-intercept we can see here is at 0. So for runner A, we have y equals 10 thirds, 2 seconds. So times 2. So that's 20. Oh yeah, sorry. 20 over 3. And the units, it says right here, meters per second. Which, by the way, is like 6 2/3. So it was in between 6 and 7. Just to find the exact one, we would need to find the equation. All right, runner B, we use the equation. Change colors. Okay, the equation is the one I circled up there for V of t. So V of 2 would be 24 times 2 over 2 times 2 plus 3. So 48 over 7 meters per second. And again, leaving it like this would have been totally acceptable. Just it might help us later on. Okay, B. Find the acceleration of runner A and the acceleration of runner B at times t equals 2